Hello, everyone. My name is Fawad Khaliq, and I'm an engineer at VMware. I work in the NSBU, and today I'm going to talk about Istio architecture for Kubernetes, Cloud Foundry, and virtual machines. So I'll talk about what service mesh is. I'll talk about what Istio is. I'll talk about how it integrates into applications, and a bit details onto one of the workflows of a packet when it flows from one application to another application once running in Istio. Let me go to the audience first and ask if you guys have used Istio or heard about Istio before. Perfect. Have you played with Istio? Perfect. OK. So what is service mesh? Service mesh is a transparent way to get a set of functionality from a group of applications that you're running. So for example, if you're running a Kubernetes cluster and you're deploying some applications, one language-independent way in which you can inject a mechanism through which you can enable things like telemetry, monitoring, policy, security, routing, load balancing, all in one using one mechanism. And service mesh allows you to do that. And what technologies enable service mesh to do it in this case? Istio was an open source project which came out last year, sometime May. It was open sourced by Google and IBM together. And since that, it has grown a lot. And recently, we had a 1.0 release. So it's an open platform which allows you to manage service interaction for containers, VMs. Mostly currently, it's container environments, started with Kubernetes, moving to other environments like Cloud Foundry or console-based environments, or also virtual machine-based environments. And the idea is that the world is moving towards containerization, microservices, multi-clouds, hybrid applications. You have a part of application running in Kubernetes and part running in, let's say, virtual machines. And you want to be able to have one layer for policy across these. Another scenario is that you're deploying your applications, and one application is running in Python, some other in some other language, and then other in some other language. And when you develop these applications, they're coming from different development teams. You have to inject a lot of additional functionality into these applications, like retries, metric collection, tracing capabilities. You have to add libraries, which you have to add inside your application code. Maybe somewhere in the constructor, or have you add every single of those calls. And they have to be homogeneous across these different type of applications that you're running to get this tracing data across your microservices, which is not just one application. It could be 5, 10, 20. So the world is moving towards where there is a fragmentation happening in terms of your application code. So it's splitting into small pieces. So management becomes harder. And then when it becomes harder, you need a way to make it easier. And Istio tries to solve that problem. So the idea is that you try to separate applications from your infrastructure. And what it means is that there is an operational aspect and there is a development aspect. Being a developer, when I'm writing applications, I don't want to worry about that my application should retry on certain things. There should be a base set of capabilities which my application should get when I deploy it. And that's like available for everyone. That's like a baseline. And I'll talk about how that gets enabled. So the goal is that Istio, when is providing these capabilities for different applications to secure, monitor, and manage these everywhere, including Kubernetes, including VKE, which is VMware Kubernetes Engine, or PCF, Pivotal Container Service, Pivotal Cloud Foundry. And the value proposition that Istio is providing over here is observability. So your applications talk to each other. You want to know some maybe tracing data, transactional data. You have a multi-tier application. You want to figure out how much level of parallelism is there in your application, how much latency is there between different parts of your application. You want to be able to control who talks to who based on different kind of attributes. For example, a certain user should not be able to access this part of the application based on your protocol, HTTP, gRPC, and there are other protocols as well that you can add inside one of the components. And also the security, when two applications are talking to each other, how do we ensure that there is no one else from outside can come and talk to your application. So for that, you can have mutual TLS-like capabilities. So I'll talk about observability, control, and security aspect. How does Istio do this all that I just talked about? The way Istio works is that it has this notion of a sidecar. The way I describe sidecar is here. Before, let's say in a Kubernetes environment, you have a pod running. A pod is a group of one or more containers. And when you write an application, you would add capabilities like TLS. So you're adding these certificates. Your application should use these when it's running to talk to another one. And you have to distribute manually everywhere. You want to collect metrics, things like how many requests went out from this application to another part of your microservices. Retry is another aspect, for example, one of the features which, when you write code, you want to make sure that that's always there. And imagine all of these app containers are written in different applications. So the way Sidecar works is that it takes this functionality, which is providing these additional features, and moves them into a concept called Sidecar. And Sidecar is another container or a process running right next to your application. The way it works is it works as a proxy. So all of your traffic goes through this proxy. Application traffic goes through this proxy. And then it can be configured to do these things like TLS, metric collection, retries, advanced routing, policy, and many other things from that perspective. So that's the concept of what Sidecar is. And we'll look at how that works in Kubernetes. So before, you would have an app container, different languages. You would write each of these things for each of those languages. Now, you would have the Sidecar, which you can just inject onto your existing running applications or new applications without changing or modifying your application code. So what is an Istio architecture, and how does this entire thing works? Istio has two parts. There's a control plane, and there is a data plane. That's an easy way to describe it for people who are familiar with SDN. Control plane has three components. Pilot is responsible for configuring parts of data plane. Mixer is responsible for doing two things. One is it allows you to do policy checks. The other one is it reports metrics, monitoring data. And Citadel is like your certificate authority, which distributes certificates to your sidecars. Let's go to the data plane. Data plane is where when your application is running. Over here, we have two applications running, Service A and Service B. Both are running proxies here. These proxies are, let's say, Envoy proxies. Envoy is one of the open source projects which came out of Lyft, which is like a smart proxy, L4 to L7 proxy. And what this proxy does is that it has its core engine and then set of filters that you can add to it for different protocols, like an HTTP filter, gRPC filter, MongoDB filter. I'm not sure how many filters are there right now. There are several, and people are continuously adding those. The responsibility of those filters is that they do protocol parsing, and based on those protocol parsing, it can give you useful information. It can look at your HTTP headers and enforce policy based on that. It can collect your stitch transactions between one microservices to the other and add transaction ID, things like that. So the configuration of these proxies happens through Pilot. Pilot has another job, which it talks to your application management system. In this case, let's say it's running in Kubernetes, so it will be talking to Kubernetes API to fetch relevant data, which it can be pushed to these proxies so that they can make these decisions when sending data from one to the other. Mixer is responsible for, as I mentioned, policy checks. So let's say one service A wants to talk to service B. If you add a policy that service B should not be getting data from service A, it will have a rule, and looking at the source of your packet, it will drop it. And Mixer is the one which provides you that. Enforcement happens on the proxy, but the rules are provided from Mixer. Other thing which Mixer provides is that when traffic is flowing from between these proxies, I'll go over details of those. Proxies can send data about monitoring, for example, and using some attributes which Mixer processes and sends to some external system. So the responsibility of Mixer is the interface between your envoys and some external systems. So it becomes like a standard API for proxies to communicate and send data or consume policies from external systems like StatsD, Prometheus, Grafana, Zipkin, etc. And Citadel is where it allows you to distribute certificates onto your proxies. Let's go over how Istio works in Kubernetes. So inside Kubernetes, Istio was developed very closely thinking about Kubernetes when it first came out. So API or configuration looks very similar to Kubernetes. First deployment was on Kubernetes. You would go and really deploy kubectl apply Istio YAML coming from istio.io. It will install all the Istio components like Pilot, Mixer, Citadel, etc., and several other things. And it would be just up and running. And even to configure policies, you could configure policies onto Istio from Kubernetes API because Istio APIs are registered in Kubernetes as CRDs, which are custom resource definitions. So they are like additional APIs for Istio in Kubernetes API format. So as you can see over here, Pilot continuously talks to Kubernetes API. And what it does is that it configures these Istio proxies, which are running with your applications. On C, there's a Golang application, another application running over there. And Mixer is also running over there, which collects data for different kind of backends like Prometheus, Stackdriver, or IAM if it's doing some policy checks over there. The deployment which happens inside Kubernetes is Istio namespace, which gets created, Istio-system, and all the components are running over there. And these proxies, envoys, or any proxy that you choose, gets injected into every single application that you launch, and you choose to enable Istio on. And there's some detail over there. You can actually, when launching an application, let's say a pod or deployment, you can decide where to inject these proxies manually, or you can enable webhooks. There's an automatic sidecar injection mechanism. You can label your namespaces, and then automatically there are webhooks inside Kubernetes which will inject these proxies onto your applications for that particular namespace. Let's talk a bit about what's going on in the world of Cloud Foundry when it comes to Istio. So Cloud Foundry team has started integrating Istio. They have been actively contributing inside Istio as well. So one of the first things they have enabled inside Istio is the Envoy itself. That's where they started. So in Cloud Foundry, you have these Diogo cells where you run these applications. Applications are built from whatever source code that you provide over there. Envoy runs as a process inside these application containers. And these envoys can be configured from Diogo cells using dynamic configuration. And let's say if a config changes inside Envoy, on the next connection, it will use the new configuration which is there. So the job of Envoy inside or PCF right now is to provide MTLS between different applications, and that's already there. There's further work going on inside PCF community to add ingress using Istio and east-west traffic as well, and some security policies. And how these will work, these are some set of features. Essentially, point is that there is Istio, Cloud Foundry community is working with Istio to enable the API integration from Cloud Foundry to Istio. So there's a component called Copilot, which translates Cloud Foundry resource changes into Istio-specific APIs, which go and configure your envoys. And there's some more work going on. They have added support they have been contributing in the areas of gateways, and there's a mesh control plane API going on, which will allow you to configure Istio in one way, not in just a Kubernetes way. So it will work across different environments like Cloud Foundry, Kubernetes, regardless of, doesn't matter where Istio is running, so it will be one API. So there's some work going on over there in the PCF community. Let's talk about some traffic workflow. So let's say service A comes up, and Envoy is injected into the service. The first thing it does is that it goes and fetches TLS certificates from Citadel or certificate authority, and it loads the configuration, routing, or load balancing configuration from Pilot. That's the first thing which happens. The next thing is that now service A wants to talk to service B. What will happen is that there are some IP table rules inside this pod. This is running in Kubernetes. So the call gets intercepted by the proxy. It will go to this Envoy. Envoy will look at its configuration on, if there's anything which a rule certain matches or where to route this to, this call to. And Envoy has these set of routes about services which are relevant or some of those. What it will do is that it will make a call. It will know that destination is service B. It will send a call to service B proxy. So communication from whatever protocol is there, let's say HTTP, it will make a call to the service proxy. In that case, when a call comes to proxy on server side, it will go and query Mixer that looking for some kind of ACL or quota check that is my client or is the sender allowed to talk to me? And if it is, it will allow the traffic. And you must be thinking, does it do for every single call? It doesn't have to. You can enable caching in there, and you can configure your own timeouts. And based on that, that improves the performance. And then Mixer sends the policy check and say, yes, you're allowed to talk to this guy. That type guy is allowed to talk to you. And these policy checks can come from built-in adapter, which is a very basic one, or it can come from an external system that you can configure with Mixer. So Mixer is an extensible component that you can add adapters to. And writing adapters is very straightforward. You can have your external component, if it's a policy or ACL component, and those adapters will start working with your Mixer if they understand the ecosystem. And the request will go to service B, which will process it, respond, and then proxy from service B will send the request back to service A proxy. When it sends it back, it will log. As I mentioned, Mixer has two jobs. One is to provide check calls. The other one is to provide monitoring or metering data. So in this case, it will notify Mixer about telemetry data and whatever plugins are running over there. If let's say there's a logging adapter running over there, or monitoring adapter running over there, for example, let's say if you're running Prometheus. So it'll send some relevant data to Mixer, which can send to its drivers and external systems through the interfaces which are written over there. And then the call will go to service A, and then service A proxy will also report to Mixer the same telemetry data that, OK, I received this call, and this was the response, and now I'm logging that to Mixer. And at that point, your entire transaction is complete. You did policy check from Mixer, and also you did some telemetry reporting to Mixer to different kind of external systems. This is very, very efficient. The way it's designed in a way is that proxies don't send the exact packets, or your proxy is not actually data plane. So it sends very small, fast consumable attributes to Mixer, which turns it into these appropriate data which can be consumed by the external system. So it makes it super fast from that perspective. All the components here, most of them can be scaled horizontally. They are stateless. And there's a new component which is coming up called Galley, which will be responsible for configuration management. It's not active right now. It's just in 1.0 release, it was just there to do some validation. The goal for Galley is that Istio will not have to rely on Kubernetes database or CRDs for storing configuration. That will be the one way for Istio to work for storing configuration. And yeah, that's about it. Any questions? Good. Thank you.